Hello students, welcome back to our channel. Students, in this video we will discuss a very important device from the chapter Mechanical Properties of Fluids of class 11th Physics. This device is Venturimeter and it is used to find the rate of flow of a liquid. But what is rate of flow? First we will discuss the term rate of flow, only then we will be able to understand what is the functionality of this device, right? So what is rate of flow? Rate of flow is, suppose we have a tube, right? Let us say we have a tube in which a liquid is flowing. This is a tube and in this tube a liquid is flowing like this, right? So what is rate of flow? Rate of flow is simply the volume of a liquid flowing through any cross section of the tube per unit time. What is the meaning of this statement? Suppose we have a tube and in this tube a liquid is flowing. Now let us take a particular cross section, a part of this cross section means let us take this part, this particular part of this tube, this part. Let us say the length of this part is delta L, right? And let us say the velocity of the liquid which is flowing in this tube is V, right? Okay, so suppose the liquid takes time delta t to move from this cross section to this cross section, right? This, let us say this end is A and this is B. So let us say the liquid takes time delta t to move from A to B, right? Okay, so the volume of the liquid which is crossing per unit time through any cross section of this pipe, that is called rate of flow, and it is represented by Q, right? So when we say volume crossing per unit time, now let us say the area, let us take the area of this as small a. We cannot take the area as capital A because capital A, the symbol capital A is already assigned to this cross section. So let us take the area of this cross section as small a. And if this tube is of uniform area of cross section, then obviously the area of this part is also A, right? So what is the volume of the liquid in this part of the tube? So volume of the liquid in this part of the tube is, volume is simply area into length, right? Volume is simply area into length. So this volume is A into delta L divided by time taken by the liquid to move from A to B is delta T. So it is A into delta L divided by delta T. And what is delta L by delta T? Obviously delta L by delta T is the velocity of the liquid, right? Delta L by delta T is what? It is distance upon time. So it is velocity of the liquid. So finally, the formula for rate of flow of a liquid through a tube is area of cross section of the tube into velocity of the liquid. Area of cross section of the tube into velocity of the liquid. So this is called rate of flow, right? Volume of liquid flowing through a tube per unit time, that is called rate of flow, and that is also equal to area into velocity. Clear? Okay, so how to find the rate of flow? If we want to practically measure the rate of flow of a liquid, then we use this device which is called Venturimeter. But to understand the working of Venturimeter, first we had to know all these formulae, and there is one more formula which we will use to explain the working of Venturimeter, and that formula is, where should I write? Okay, I'm clearing this off because this was just to explain this was just to explain the working of Venturimeter, right? You need these formulae to understand the working of Venturimeter. We have just not started the main part, right? So there is another concept which is needed to understand the working of Venturimeter, and that is equation of continuity. That's why I'm writing all these things on this side, because we have not actually started the working of Venturimeter. We are just studying the concepts that we need to understand the working. Equation of continuity. Equation of continuity. This is the another thing which is needed. So what is equation of continuity? Suppose we have a tube of non-uniform area of cross section, right? So the area of cross section of this part is clearly more than the area of cross section of this part. Area of cross section of this part is, let us say, A1, and area of cross section of this part is, let us say, A2, right? So the liquid which is flowing in this tube has velocity v1 at this cross section, and it has velocity v2 at this cross section. So equation of continuity says that a1 v1 is equal to a2 v2. a1 v1 is equal to a2 v2, right? Which says, what is the meaning of this equation? It says that the product of area of cross section and velocity of liquid at any cross section is always same, right? So the product of area and velocity at this cross section and the product of area and velocity at this cross section, both these products are same. Or if we take this product at any other cross section, then that also will be same. Which means that if one of these increases, then the other one has to decrease to keep the product same, right? We can clearly see that the area A2 is less than area A1. So if the product A1 V1 and A2 V2 is same, then obviously if A2 is less than A1, then V2 must be greater than V1. So the velocity of liquid at this cross section is more than the velocity of liquid at this cross section, which means when the area of the tube decreases, the velocity of the liquid increases. It happens when you are in garden, when you are giving water to plants. So when you press the mouth, the opening of the tube, then the speed of the water which is coming out of the tube increases, right? So that is happening due to this equation. When you are reducing the area, you are pressing the opening of the tube, then you are reducing the area. So when you are reducing the area, obviously the velocity of the liquid which is coming out of that part will increase, right? So this is the second equation that we are going to use to explain the working of Venturimeter. So and we know what, that the product of area and velocity is nothing but the rate of flow. So this equation indirectly saying that rate of flow always remains constant. Rate of flow is constant, right? Rate of flow is constant. Clear? Okay. Now let us start the working of Venturimeter. So what is Venturimeter? Venturimeter is used to find the rate of flow of a liquid. Okay. What is the design of Venturimeter? Venturimeter has two parts. One part is a part of broader area of cross section, and there is another part which is of narrow area of cross section. Right? This is a broad part and this is a narrow part, and you can see the openings. Here are the two openings, and these two are connected by the two limbs of a U-tube. Not the YouTube on which you are watching this video, but a tube of U-shaped, right? This. Okay, so the liquid whose rate of flow is to be measured is passed through this pipe of non-uniform area of cross section. Now this is the liquid flowing through this tube. Let us say the area of this cross section is A1. Area of this cross section is A1 and area of this smaller cross section is A2. And the speed of liquid is V1 here and speed of liquid in this narrow part is V2. Obviously V2 is more than V1. Now there is a third equation which is used to explain the working of Venturimeter, and that is a very famous equation which is called Bernoulli's theorem, right? If we say that this tube is horizontal, then obviously when the liquid is moving from this part to that part, then the potential energy of the liquid is not changing because there is no change in height when the liquid is moving from this part to this part. But kinetic energy will change because velocity is changing, and pressure energy will change, right? Because pressure is also changing. When the velocity changes, then pressure also changes. So let us say the pressure of the liquid here is P1 and the pressure of the liquid here is P2. Okay. In this U-tube, there was a liquid which was in equilibrium when this liquid was not going through this tube, right? Since this liquid was in equilibrium, so the level of the liquid in both the limbs was equal. But when this other liquid whose rate of flow is to be measured is starting flowing in this tube, then obviously there is a pressure difference which is created. Now, which pressure is more, P1 or P2? For that, we have to use the Bernoulli's equation, and Bernoulli's equation says that the sum of potential energy per unit mass or per unit volume and sum of potential energy, kinetic energy and pressure energy per unit mass or per unit volume at one cross section is equal to the sum of pressure energy plus kinetic energy plus potential energy per unit mass or per unit volume at some other cross section, right? Okay, so pressure energy per unit volume is P1 and kinetic energy per unit volume is half rho V1 square, and the potential energy is not changing because this tube is horizontal, so the height is not changing as we have discussed earlier. So this is the sum of pressure energy per unit volume and kinetic energy per unit volume at this part, and this is the sum of the same thing at this part, right? So as velocity V2 is more than V1, since velocity V2 is more than velocity V1, so to keep this product same, obviously pressure P1 must be less than P2, pressure P1 must be less than the pressure P2. Velocity, wait. If the velocity at this point is more than the pressure at this point is less, only then this sum will be equal. Velocity at this point is more, so pressure at this point, that is P2, is less than the pressure at P1. So P1 pressure ज़्यादा है, right? P1 pressure is more than. Okay, so this pressure is more than this pressure. So this pressure is less than this pressure. So what happens? This liquid will move to this point, right? Due to this less pressure. This pressure P1 is more than this pressure. So this pressure will press the liquid from this side. So this will go in the downward direction, and here in this limb it will go in the upward direction. So the equilibrium of this liquid is disturbed, and now the final position of the liquid is such that there is a difference of height in both the limbs, right? And let us say that difference is h, right? Let us say that difference is h. Okay, so this equation can be written as P1 minus P2 equal to, this is coming on this side and this is going on that side, so P1 minus P2 equal to half rho V2 square minus V1 square, V2 square minus V1 square, right? Okay, so let us take this as our first equation. Also, now let us say the density of the liquid which is flowing in this tube, whose rate of flow we are measuring, and the density of that liquid is rho, and let us say the density of this liquid is rho m, right, which is in this U-tube. So if the pressure here is P1 and pressure here is P2, then obviously the difference in the pressure P1 minus P2, also P1 minus P2 is H rho m g, right? Now this is the another formula which is being used to explain the working of Venturimeter. All these concepts are from the same chapter, so there are 4 or 5 fundamental concepts which we are using to explain the working of Venturimeter. So we cannot explain all the concepts in detail because this video is targeting just the working of the Venturimeter, right? So you must know that the pressure difference, when the difference between the heights of the liquid in two limbs of the U-tube is h, then the pressure difference P1 minus P2, which is the pressure difference between the upper points on both the limbs, P1 minus P2, that is H rho g, where rho is the density of this liquid which is in U-tube, and that is taken as rho m. So H rho m g. Okay, and also now this is the second equation, and also A1 V1 equal to A2 V2, and this is the third equation that we will use. Now let us take this equation, and in place of P1 minus P2 we will write H rho mg. In place of P1 minus P2 we have written H rho mg, and this is half rho. Now let us take V2 as common, V2 square as common, so 1 is left here, and V1 by V2, because we have taken V2 square as common, but there was no V2 square in this term, so we have to divide this term by V2 square if we are taking V2 square common from this part, right? Okay, and since A1 V1 equal to A2 V2, so what is the value of V1 by V2? What is the value of V1 by V2? The value of V1 by V2 is simply A2 by A1. Okay, so idea is to substitute more and more known terms in place of variables. Obviously, we have no idea about the velocity of the liquid in this part and in this part. If we would have known the velocity of the liquid, then why we will do all these things just to find the rate of flow? We can simply multiply the velocity with the area and we'll get the rate of flow. But we do not know the velocity of the liquid, so it is needed to substitute the velocity of V1 and V2 in terms of some known variables, and obviously the area of the cross section of this broader part and this narrower part is known, right? So we can substitute V1 by V2 by A2 by A1. So H rho m g equal to half rho V2 square 1 minus A2 square by A1 square. Okay, so finally we will write it like this, rho mg equal to half rho v2 square a1 square minus a2 square v2. So what is the value of v2 square? What is the value of v2 square? The value of v2 square is 2, this 2 is taken on that side, 2h rho m g into a1 square divided by rho into a1 square minus a2 square. And what is the value of v2? Value of v2 is the square root of this. So if we take the square root of this, a1 square is out of the square root, so it becomes a1 2h rho m g divided by rho into a1 square minus a2 square, right? Okay, but what we are finding? We are finding the rate of flow. So what is rate of flow? Rate of flow is either a1 v1 or a2 v2. Since now we know the value of v2 in terms of all the known constants, we know the area of cross section, we know the difference in heights, we know the densities of both these fluids, we know acceleration due to gravity. So we can find v2 using this formula. And since rate of flow is v2 minus what I'm writing, rate of flow is a2 into v2, and we know the value of v2. So what is rate of flow q? Just multiply this by a2. So a1 into a2 under root 2h rho m g divided by rho into a1 square minus a2 square, right? So this is the formula which is used in Venturimeter to find the rate of flow of a fluid, and this formula can be used because all these values are known, right? So this is the working of the Venturimeter, and this can be called the derivation of this formula, and it is a very important topic in class 11th physics, right? So when this question comes, you have to draw the diagram also, you have to derive this formula also. So you have to prepare it by yourself by writing it in 3 to 4 times, right, in your notebooks. So I'll meet you in the next lecture. Till then, all the way.